Okay, so the title of this question kind of indicates to us what we're looking at here because it says that no reaction goes to 100% completion. So what they're giving us here in the first problem is they're giving us 205 millimoles of H2 and 205 millimoles of I2. In other words, they're giving us these two things. Now, the only direction when you have none of this, the only direction the reaction can go is in this direction. Agree? Now, what we know is that at the very instant the reaction starts, there's nothing over here. And we'd have 205 millimoles of this and 205 millimoles of this. But as soon as the reaction starts going, a little bit of it is going to rebel and go back the other direction. So at the beginning, it's going to look like this. But over time, the amount of products reforming the reactants get bigger and bigger until eventually the forward reaction rate and the reverse reaction rate are exactly the same, and there's no change in the amount of products versus reactants. What that means then is this. If we start off with 205 millimoles of this, and we start off with 205 millimoles of this, altogether, by the way, that's 410 because of my amazing math skills. And of course, I wrote 400, but 410 millimoles, right? We can assume that when we look at how much of the HI will be produced, that none is not going to be an answer because the reaction's going in this direction. Now, well, we know that some's going to go across, but less than 410. So the other thing is, if no reaction goes to 100% completion, it means that not all of this stuff over here is going to go all the way over here. So we're not going to have either of these two scenarios, 100% on one side and 0 on the other, or 0 on one side and 100% on the other. So that gets rid of our options of none and 410, right? Now, here's where it gets a little silly, because unless we're creating matter, there's no way that we can have more than the 410 millimoles we had. So by process of elimination, that leaves us with some, but less than 410. So we're gonna box this in. Now they go the opposite way on this, and they say, all right, let's get rid of this because it makes my head hurt. Now they go over here and they say, all right, what if we went the opposite way? What if we started off with 135 millimoles of this, and it's empty? Now remember, reactions can go either way, and they're always going to meet their equilibrium constant, which we'll discuss probably later. But if I only have this and I have none of anything on this side, the reaction is going to have to go back in this direction, right? So if we start off with 135 millimoles of HI, and that's it, the only direction we're going to go is this direction. And because no reaction goes to 100% completion, we're going to go back and say, well, how much HI will we have at the end? Well, will all of this go over here? Well, the answer is no. That's not the case. Some, but less than 135. That's a pretty vague answer, but in reality, it's true, right? Because some is going to go over here, but it's not going to be the full 135 because, again, nothing goes to 100% completion. So I'm going to put a little check mark by this, but let's just verify the other side. So the other one is saying 135 millimoles will be how much we have of this at the end. That would essentially be saying that nothing went across. And then again, in the we want to create more matter than exists world, you cannot have more than what you started with here. So of all of our choices here, the sum, but less than 135 is the correct answer. Hope this helps.